Quick review that we shifted from lines of evidence to kind of the genetic basis of natural selection and what it does to bell curve type polygenic traits. And so we used the example with the aliens for directional selection, where they killed all the tall people and the curve shifted to the left. We used baby birth weight and head size for stabilizing selection, because of course there's that hard limit on the high side and then on the low side as well. So the curve kind of just squishes and stays in place. And then we use the aliens again for disruptive selection, where the aliens are just taking out the average height people, and the curve gets that kind of dip in the middle. And that's the interesting one, because it can lead to what we call speciation. Because if the two phenotypes get different enough, then if they're not interbreeding anymore, evolving independently, they can become two different species. Any questions about those? Everybody good so far? Quick detour. We'll continue with speciation in a second. Let's just talk about traits for a second. This genetic variation that you have to have for natural selection. Doesn't work without it, right? You need genetic variation, you need over reproduction, you need competition. Where does the genetic variation come from? Where do you get new traits? Teacher school, this is called wait time. It always seems way longer than it actually is. Where do new traits come from? Ultimately, new traits come from mutations. Remember, the mutations, naturally occurring mutations, mainly happen as errors in copying DNA. You got all this machinery to keep it from happening, to correct it when it does happen, to not let it get out of the cell it starts in, but every once in a while you mess up. And thank goodness, because that's where the good new traits ultimately come from. You can't have new traits without it. And that is what you get when you Google mutant. I don't know that any of those pictures are even real, but I just wanted to spice things up a little bit. Anyway, that's where new traits come from. Then, of course, there's the other driver of variation, the thing that sped up the evolution of life on Earth, and that would be sexual reproduction. Sexual reproduction increases variation. And if you don't know the two things that go where that question mark is, you haven't been paying attention. Crossing over an independent assortment in meiosis 1, specifically late prophase 1 and metaphase 1. Yeah, you take what your parents gave you, you scramble it up before you deal it out to your kids. That way increases the differences between members of any sexually reproducing population. It's great. It makes evolution happen faster because it increases diversity. However, don't make the mistake of thinking that sex actually creates diversity. It doesn't make new traits. It just scrambles up the ones that are there. Speciation basically is when a population evolves to become different enough from its ancestors and/or, well, sometimes and, a separate population that it's split from, that we consider it a separate species. And how do we typically define that separation? How do we know when they're different enough to be considered separate species? Veda? What's our practical way to tell if they're different species or if they're the same species? Remember our example with the aliens, where the short people and the tall people? And so if they don't like each other, they don't. And if they don't interact, they don't. That's the one. Yeah, we define practically. Now, it's not foolproof, but our typical way of dividing, okay, they are different species now, is they're not mating anymore. And we call that reproductive isolation. That's kind of the line. Well, certain kinds of reproductive isolation. The first kind of reproductive isolation doesn't necessarily mean we're looking at two species, because populations get separated all the time. Amanda, what's a way that one population might get split into two? Birds, squirrels, whatever. Give me it. Just off the top of your head, what's a way you can picture that happening? No, like they're all together and then suddenly they're separated. How did they get separated?
Like discrimination.
Like physically. Flock of birds is flocking along, and they get split into two groups. How did they accidentally get split into two groups? Thank you. Huh? Okay, sure. A big predator, a big old orca jumps out of the water. They're flying over, scares the crap out of them. They scatter into two groups. They wind up on two separate islands. They don't see each other again. Give me another example.
One group of them is really big and they just start attacking or something, they're hostile.
You guys are weird. Like you're going for all the stuff that comes later. I'm looking for the most basic thing that can happen. Like what? Give me an example.
Storm.
In a storm, how would that separate a population into two?
It prevents them from like interacting. Like if there's a bird, they can't really fly off.
Sure. Maybe the storm, it scatters the one population into two and they can't find each other again. Maybe the what were you going to say? So maybe there's a bunch of squirrels and then there's an earthquake and there's a big crack in the earth and the squirrels can't get to each other anymore. Maybe there's a flood and the caribou, this flood comes down the middle of the herd of caribou and now there's a river there and they can't get to each other anymore. That kind of very simple physical separation. It's not that they don't want to, it's that they just can't get to each other. That one's called geographic isolation. That doesn't necessarily make them two different species, but it does quite effectively start them evolving as separate populations. So geographic isolation is often the first thing on the road to new species. Then we get into what Amanda was thinking of. Because once you start changing independently of another group of the same species, depending on how picky the members of your species are about mates, you know what the pickiest tend to be? Pickiest species? Birds are so picky. It's about the right colors or the right. Do you ever see the bird of paradise dances? Yeah, on like the planet Earth, or there's a bunch of different shows that have it, but they're so ridiculous. The males have to do these just elaborate, like all these crazy dances to impress the female. And the female's just standing there like, and if it's not perfect, she's like, mm-mm. And the dude has to just like fly away. It has to be exactly right. The song, if it's a song, has to be perfect. And if it's not, nope, not happening. Well, as soon as you're geographically isolated, and you start evolving independently, it doesn't take much change, for birds at least, to not be into it anymore. And so even if then they, the river goes away, or they find each other on that same island again, they're not gonna be into each other at all. They won't. It's not can't anymore. It's won't. And if it's won't, that is a marker of two different species. That's called behavioral isolation. Not always about behavior, though. Sometimes it's about timing. Sometimes a split population, one half of that population, one of those new populations has to change the time of day it does what it does. Maybe there's predators out during the day, so it's got to, the only ones that survive are the ones that hang out at night and get food at night because there's no predators then. Well, if that happens and one population that used to be the same species is now nocturnal, and the first population is still diurnal, and they come back together, they're not going to see each other anymore. That's as effective as won't, right? It's basically, where are they? They're not going to see each other. They're not going to mate. If it has to do with timing, it's called temporal isolation. It doesn't have to be time of day that they're around. It can be time of year that their mating season is. Maybe their mating season is shifting in the other population. So later in the spring, and later in the spring, the first population's mating season is the same. Well, as soon as they don't overlap anymore, even if they come back together, they are reproductively isolated. We call that temporal isolation. Temporal means having to do with time. But okay, so this is two sets of three you've had here. Three kinds of selection on bell curves, three kinds of reproductive isolation. It's kind of hard to picture. So let's try and use an example that hits all of them. We're gonna look at finches. The kind of remarkable thing about Galapagos finches, the reason scientists have studied them for so long, is that from one species of South American finch that got, I don't know, blown off course from South America and wound up on the first Galapagos island it wound up on, we now have 13 different finch species. Went from 1 to 13 in geologically a pretty short amount of time. And so this is a model, a sort of theoretical example of how that might have happened. You don't have to draw the pictures I draw. They're going to be terrible. But you can if you want. Oh, I said black. For example, this is my South America. And okay, so let's picture an ancestor species of finch getting caught in a hurricane or something and winding up, getting blown off course onto our first Galapagos island. We'll call that G1. This is island G2. And here's our cute little finch. Oh, this is going to get worse before it gets better. It's a finch. Okay, so the foundling population arrives. And then some of that population wanders over to island G2. That's a much healthier looking bird. We're calling this population A. These are bird A, species A, right? But what happens is on island G2, things are different. Things are different. In fact, the food that's available on island 2 is different. The seeds that those finches can get are big, spiny, tough seeds. And all the first year, a ton of those finches die. The only ones that survive are the ones that have bigger, stronger beaks because they can crack the big seeds open. So what happens is gradually, or actually fairly suddenly is the way it actually happened, those A birds get significantly bigger beaks. Because all the little beak birds die. Well, let's put it to the test. Population B comes back to island G1. And the A birds are like, ew. Gross. Look at your big, disgusting beak. No mating. That's behavioral isolation, right? We started with geographic. That's when it gets separated by the islands, right? Then from little to big beaks, what kind of selection is that? What kind of natural selection on the bell curve happens? That was directional selection that gave them the big beaks. Now they fly back and A won't mate with them. What kind? That's behavioral isolation, right? We've gone from geographic to behavioral. All right, well now, okay, we're not done because now that A and B aren't mating and they're on the same island, what's their relationship now? They're competitors now. You better believe their niche, we said competitive exclusion, right? As soon as their niches overlap enough, somebody starts to win, somebody starts to lose. It's back from our ecology chapter. Well, it turns out it's the B birds that start losing. They're no match for the A birds because the A birds, the little beaks and the little seeds on the island 1 are a good match, and the B birds are getting competed out. So if they're there at the same time as the A birds, they're clumsy and they drop the little seeds and the A birds snatch them out from underneath them. Except that what happens is a bunch of the B birds starve, and the ones that make it are the ones that go foraging for seeds later and later and later in the day. And pretty soon, the B birds, there's these B birds here, but the B birds that went back to the island where the A birds were have evolved to where they're all about evening foraging. They're not even out at the same time as the A birds anymore. And in fact, if they went back to island 2, they wouldn't even see the B birds that are still there. They'd be out at a different time as them as well. So they've now officially evolved into our population C. What kind of isolation was that? They're not out at the same time anymore. What do we call that? That's the temporal one. So we've seen all 3 kinds of isolation. We've seen directional selection. And basically, it's not too hard to jump from that example have the same things happen a few times in different ways. Not too hard to envision one species becoming 13. On Monday, we'll watch a 15-minute movie about the cute little British couple that has been going to the Galapagos every year for 50 years and has actually seen stuff like this happen and measured it. Very cool story. For now, with the test coming on Wednesday, I'm going to give you sample essays, let you work on those.